Hello guys, welcome back. So today we are going to see today Leetcode question, right? And sorry for the late today. Actually, I was a little busy today morning, so I have not put the code on time. So let's continue today question. Okay. So today question we have is 71 simplify path. Okay. So this question is actually very important because most of the interview has asked this question like in the FANG and top-notch private you can say product-based companies, right? So let's read the question first. This is the 71 Leetcode question in which it is saying that simplify path, and we have given a string which is an absolute path, right? We have a string path which is absolute path starting with a slash, right? And to a file or a directory in a Unix style file system. So we have to convert it to simplify the canonical path, right? So I think you know the raw path or canonical path, right? So that we have to understand. Okay, so absolute path in which slashes are there and there is some canonical path in it, means user readable path are there, right? That we have to convert into that, right? That we will see in later. Okay, now understand, in a Unix style file system, a period is dot, right, refer to the current directory, correct, and a double dot refers to the directory up a level, right? Directory up a level. So if you already aware with that, like dot refers to the current directory and double dot refers to, you can say, directory up a level, one level up, right? And any multiple consecutive slashes, right, treated as a, you can say, single slash, correct? That we already knows, right? If you have already done file system programming or either in the Windows or Linux, right? So you will be aware of this one, right? Even if in Java, if you directly put into copy the single slash from somewhere to you will put, right, it automatically treated as double slash, right? So you can remove one slash also, but so that you can say double slash is also treated as a single slash, right? You already aware of this one. Now consider that for this problem, right, any format of the period such as triple dot are treated as a file or directory name. If there is any format, right, of the period, if contains triple dot, right, or either triple dot, you can say, so it's you can consider it as a file name or something else, okay, or directory name. Now consider what is the canonical path. The canonical path should have the following format, right? The path start with a you can say single slash or any directory are separated by single slash, right? And a path doesn't end with a trailing slash and the trailing, right? And in the last, you can say, and the end and the path only contains the directories on the path from the root directory to the target file or the directory no period dot or double period have, right? So we have to return the canonical path, you can say, in this way, right? So these are the you can say things we have given, right? And what we have to do, we have to do the implementation for this program, right? Means we have given the raw we have given that is called absolute path, and we have to convert into canonical path, right? Actually we have to convert this, right, you can say, and after simplifying that we have to return the canonical path, right? So I think the best approach you can use is using stack, right? So why? Because this is a direct implementation of one of the most common commands used in one of the form of other, you can say, on all the famous operating system, right? So for example, if you'll understand this directly translate to a part of implementation of cd command, right? You know the cd, change directory, right, command functionality in the Unix operating system. So it basically help us to change directory, right? And obviously there is much more it than simply figure out the smallest path of the you can say final directory where the user wants to go, and there is a kernel level, right? There is a kernel level implementation that is involved that actually uses the underlying file system to change the directory. Like you are into the one of where you want to go, right? And you might argue that nobody would go crazy on the command line and want to run something like, let's understand, if we write something like, if you write cd, right, then you write a, then you write B, then you write something C, right? And after the C you can put what, 2 dot, then you will put single dot, then you will put single dot, then you will single dot, there may be double slash, then you will put another directory, right? So like this, right? So you might argue that nobody would go crazy on this command line and want to run something like this one, right? However, our code needs to able to handle the different scenarios, right? And all the special characters, like if you use something like, you can say dot, right, comma, double dot, comma, or as you will also say slash dot. Okay, so these things should have to handle, right? So our code needs to needs to be able to handle the different scenarios and the special characters like these, right? We have to handle, right? So all these weird scenarios will be taken care of a couple of checks, right, here and there, like that. So the main idea for solving this problem would remains the same, right? So the heading of this approach mentions the, you can say you have the data structure, right, that we are going to use, that is called a stack, we have mentioned, right? So however, we are going to work our ways, we are going to work our ways through the problem, and so as to understand as to why a stack, right, fits in here. So let's understand, let's see tree is a representation of a simple directory, right? So what I'll do, better let's understand here only. Let me clean, coming back to here, yeah, that's all. Okay, let's understand. We have some directory like this, right? We have initially a directory we have, right? So in directory we have slash, right? So this directory contains a directory that is, let's suppose we are talking about A, we have A, and this directory, if we will represent, we will write like this, right? If this directory contains two directories, let's suppose we have we are taking B, right, and another directory we have also is D, right? Two directory have B and D. If B directory is going to another directory, right, and that directory is nothing but C, right, like this, and D directory going to E, let's suppose. Okay, so in this case we will write slash A, correct? And if we have to write this B, then what we will write? We will write slash A slash B. If we have to write this directory, how will represent? Slash A slash B slash C, correct? If we have to represent this one, how will we write? Slash A slash D, correct? If we have to represent this one, then we have A, D and E slash D, right? Like this we will represent, right? Okay, so that's why we are going to see. Now suppose that the path like slash A, B and C, right, this one, slash A, B and C, we add another example. We can say it will put like this, slash A slash B slash C and something dot, right, like this. So now this is interesting, because if we write double dot, right, if we'll write double dot after this, let's suppose we are talking about only these two, there is only two. Okay, so is it if we will write this one, right, so double dot, right, so double dot is no longer a subdirectory name. As you can see, only we have what after this, this is our root directory actually, right? So root directory we will write only slash, right? So on the root directory we have A, B and C, three levels we have, three subdirectories we have. After C we don't have any directory, right? So no longer a subdirectory name we have. So it has a special meaning, right, and an indication to the operating system to move up on one level in the directory structure, thus transforming the overall path to just slash A and slash B. Got it? So it's you can say it's like if we pop out the subdirectory from C, right, C from overall path, right, there that's the correct idea of this problem, correct? So if you think about it, and the only actionable special characters is what? Double dot, right, double dot. So the single dot is kind of no operation, because it simply means the current directory. So nothing changes in the overall path as such we have, right? So now now understand, we have a general idea about how this problem can be potentially solved using the stack. Okay, so let's get right into the algorithm, and let's understand how we'll do that, right? So first of all, see what we will do, right? First of all, we'll take a stack, right, and then we will do the implementation. Okay, so better we will go to the program and we'll do the implementation, right? So as you can see the example we have given, let's understand the examples also. We have example, we have given this one, right? Path we have given like this, right? So we will return this output like this. So there is no trailing slashes, right, after this, and this is the last directory, you can say. If you'll do like this, right, if slashes means it means directly like this only, as we have talked, right? So it is going one level up of the root directory and no pop-ups, right, that we are talking about. And the root level is the highest level as you can go. If we'll talk about the path example third, what we have slash home, then we have double slash, then foo. It means what? We have to represent these two slash into a single slash like this, right? As you see. I think you got it, okay? And if you understand about the constant, so length could be greater than or equal to 1, less than 3000, and path consists of English letter, digits, slash, dot, hyphen. These are we have given, okay? And path is a valid, absolute, Unix path we have given. So this question is very, very important because see, multiple times the Facebook have asked this question, Amazon has asked this question, Google has asked this question, and my company Oracle has also asked this question. Okay, I mean Oracle actually. So Oracle has also asked this question, right? So these questions has been asked. Now understand about the string and stack. Okay, let's go understand. So I think we have already understood. So let's go to the browser section and we'll do the implementation. And let's do the hands-on, right? So first of all, what we should do, right? First of all, what we have given you can say we have given path, right? So first of all, we will initialize a stack, right? To do that, what we will do, let's initialize the stack. So to initialize the stack, what we will do, we will create a stack, right? How we'll do that? Let's say this is a stack, and we'll take what new, and this is our stack. We do implementation like this, right? And to do this, what we have to do, we will take here, right? We have to define the definition, right? And to do that, what we have to do, we have to say stack, right? And the type, generic type we have to define, and this will take what? String, right? We'll take a string. Now our stack is ready. Okay, now we have initialized our stack. We will do the initialization of the stack. Now we have to split the input string using slash as the delimiter, right? So this step is really important because no matter what, the given input is a valid path and we simply have to shorten it, right? So means we have to do sort. So it means that whatever we have between two slashes, two characters in a slash, right? Either a directory name or a special character, right? So we have to process them accordingly. Let's understand how we'll do that. So first of all, we'll take a string, right? And in string, this is nothing but our array. Okay, so I'll name it as a component, right? Components, suppose. So components of I'll do a string, right? Component of string, I'll do name, and component string you can give the name, and I'll take here this one, what we say, path, that we have given path is path, right? Over this you can do split, right? This one, and then what we will pass in the double slash, we will pass like this, right? Means now we have a split the input string using this delimiter, right? And this step is really important because what we will do, we have to check the input, given input path is valid or not. That we will continue, that we will see, don't worry. Now now what we should do, we will once we are done with the splitting the input path, right, we will process one component at a time, right? So split the input string with a slash as a delimiter, and each process portion one by one we will do. Let me write so we'll understand. So first of all, what we will do, we'll take a string directory, right? Let's suppose this is directory. I'll take dir, and another what we will take from the component, right? We have already the component, right? Component, component string, right? So from the component string, one by one I will get a directory. Okay, and this directory will check, right? Once we have the directory, we will check if the current component is a dot or an empty string. We will do nothing and simply continue. Well, if you think about it, like the split string array for a string slash a double slash b, right? We will do, then would we will put into a and a into b, like will do, right? And that's a empty string in a simple simply you can say in the a and b, right? Two string will take, right? So again, the perspective of the overall path, it doesn't matter anything, right? Means what I'm trying to say, if we'll make a condition, right? Let's suppose if I'll make a condition, okay, and this condition, if a no operation for small a, will do dot, right? Or any empty string, right? So we have our directory, right? So if this directory will do equals, right? Will do equals, and we'll put what? Nothing but our if has single dot, means we have single dot, or we'll say directory dot is empty, right? Like this. If this either of these two we have, right? Either directory is having dot, or if the directory is empty. In both cases, what we have to do, we will not do anything, just we will do continue. Or if that is not the case, means if else if, right? We have directory, and that directory contains what? Contains not contains, will take equals, right? Equals, then we should pass what? If it contains double you can say dot, right? Double dot, like this. Okay, if we have this one, right? In that case, what we will do, right? Means if the component contains, if the component is a, let's suppose, and we have two double dot, right? In that case, we will pop an entry from the stack, and if it is not empty, we will check next what we should check, right? So we'll check like we are not stack we have, right? So on our stack we'll check is empty. If it is not empty, like this, if it is not empty, means that we have to do pop. Got it? So first time we will not do, but if it is not empty, then we'll do pop. Means if our current component, let's suppose a, we have a double dot, right? In that case, we pop an entry from the stack, and if it is, but we will check if it is not empty, right? Only that. Now coming back to here, right? Now we'll do else condition, right? We can take here, right? And after coming to here, right? We'll say else, yeah, we can take here. If directory is this, if directory is yeah, we are fine. Now what we should do, finally we'll take a legitimate directory name and we add it to our stack, right? So to do that, what we'll do, we'll stack dot we'll took add, yeah, stack dot add, and we'll put what? Our directory dir, right? So what we have done, we have finally added into our stack. Now our stack contains is directory at a time. Now all directories we have, right? After that, what we should do, we are done with our component. All component one by one directory will take and will put into our stack, right? If not required, we will remove from the pop. We will do a stack remove. Now we have to stitch together all the directory name together, right? So how we will do that? We'll take a string builder. So we'll take a string builder and we'll say, let's suppose we'll give our canonical path, right? Canonical underscore path. Okay, so this is our canonical, let's put like this only. This is our canonical path, right? And this canonical path will initialize like what? New string builder, right? Like this. Now our stack contains data, right? Let me go here. Okay, now our stack contains data, right? So from the stack we'll get one by one string. We have string, we have our directory, and this will come from what? Stack. and this stack will give you what our we have canonical path, right? So on the canonical path we'll do what? Append. So append is the method in which we will first pass slash, and then we will add our on the canonical only canonical path dot append what? We'll pass our directory one by one. Now it is done. Now what we should do to return our final thing, what we have to do here, we have to return, we have our canonical path. So canonical path dot will take length. If length is canonical path length is what? Greater than 0, right? If it is greater than 0, then we'll pass our canonical path dot to string, and then if not, then pass slash, like this. Let me zoom out a little bit. Okay, so let's understand what I have done. First of all, we will take a stack, that is a string. It will take a string. Then we'll take a components, you can say string, and from each component we have taken a path split, right? So each component contains as a, you can say, correct string array, right? So from one by one component we'll take a directory and we'll check if it is dot, if it is dot or empty, we'll not do anything. If it is not double dot, then we what we'll do, we'll check stack is empty, not empty, then pop, otherwise we'll add. We'll take a string builder path and we'll append our path, and as well as our directory will append. We'll check if we got our canonical path, then we will return. Yeah, this is working. So let me submit this one. Great, it's working. So now what we will understand, so see, time for the time complexity, space complexity, see, we are going for all the directory size. So if there is n character in the original path, right, in this path, if we have n characters, so we spend O of n trying to split the split here, right? Each time we will split into user component, and then we will process each component one by one, so which is again will take O of n operations. So we can get rid of splitting the part and just the string together, right? We are doing, right? We are doing here, and we are appending, right? So it will take to do stitching again, right? So it will take, we are using the stack also. So we know that the main idea of the algorithm is to use a stack, and how you decide to process the input string is a personal choice, right? So it's all I'll say the time complexity and the space complexity is will take we are taking you can say splitting and stack, right? So space complexity and time complexity both will be O of n. So thank you guys, thank you for watching this. If you like this video, please hit subscribe so that you will get more videos like this. Thank you so much for watching this video.